What are the real or imaginary solutions of each polynomial equation? Starting with this one, 2x to the third minus 5x squared equals 3x. You need to get everything to one side equal to 0 to solve this for x. We're going to subtract 3x from each side. When you do that, you get 2x to the third minus 5x squared minus 3x equals 0. So that 0 is really the y value. We're finding the value of x when y is equal to 0. Or in other words, we're finding the x-intercepts. To solve this for x, look for a common factor that you can factor out. X is a common factor to those three terms. So if you divide each term by x, that's what goes in the parentheses. If you divide 2x to the third by x, that is 2x squared. Divide negative 5x squared by x, that'd be negative 5x. And if you divide negative 3x by x, that is negative 3. So inside the parentheses, that will still factor into two binomials. But you have a 2 in front of the x squared. So you have to do factoring by grouping. You need to split that negative 5x into two terms. Their coefficients would multiply to get what 2 times negative 3 is. So they multiply to get negative 6, and they add to get that middle coefficient of negative 5. So two numbers that multiply to get negative 6 and add to get negative 5, that would be negative 6 and 1. So that middle term, that negative 5x, splits into negative 6x and x. Now inside the parentheses, continue factoring by grouping. Group those first two terms together and factor out a common factor. The common factor to those first two terms would be 2x. So if you take a 2x out of those first two terms, you're left with x minus 3 in parentheses. Then group the last two terms together, the x minus 3. Now you look at those and you think there's nothing to factor out, but you can always factor 1 out. So divide each term by 1, and that's what goes in parentheses as well. So you have 1 times x minus 3. You have to get the same thing in the parentheses in order to continue. We have x minus 3 in the parentheses. That is a common factor, and that's what gets factored out next. So we're going to take that x minus 3 out of those two terms, and we're going to be left with 2x plus 1. It's just like erasing the x minus 3. You have 2x plus 1 left over, and that's what that factors into. Don't forget, you have the x out front. So x times x minus 3 times 2x plus 1. That's all equal to 0. So those three things multiply together to equal 0. That means any of those three things could be equal to 0. So set each one equal to 0. Set x equal to 0, x minus 3 equal to 0, and also 2x plus 1 equal to 0. And then solve each one of those for x. Well, that first one's already done, x equals 0. The second one, x minus 3 equals 0. Just add 3 to both sides, you get x equals 3. And on the end, 2x plus 1 equals 0. Subtract 1 and divide by 2. End up with x equals negative 1/2. So those are the x-intercepts. Those are the roots, the zeros, the solutions to that equation. X equals 0, 3, or negative 1/2. Remember, the degree of the equation, the degree of the function, will tell you how many solutions you'll get. So the degree is 3, and we do have 3 solutions. 3 x-intercepts, 3 places where that crosses the x-axis. So when I graph this, you can see it hits the x-axis at negative 1/2, at 0, and also at 3. So x equals 0, 3, and negative 1/2. We're going to solve this equation for x. 3x to the 4 plus 12x squared equals 6x to the third. To solve that for x, you need to get everything to one side equal to 0. So that 6x to the third needs to be moved to the left side. To do that, you're going to subtract 6x to the third from each side. And when you do that, you get 3x to the fourth minus 6x to the third plus 12x squared equals 0. Always look for a common factor that you can factor out. 3x squared is a common factor to those three terms. So when you factor 3x squared out, you're dividing each term by 3x squared. And that's what goes in the parentheses. So if you divide 3x to the fourth by 3x squared, that is x squared. If you divide negative 6x to the third by 3x squared, that is negative 2x. And if you divide 12x squared by 3x squared, that is 4. So we have 3x squared times x squared minus 2x plus 4 equals 0. Now you might try to factor this that's in the parentheses into two binomials, but it doesn't factor into two binomials because there are no two numbers that multiply to get 4 and add to get negative 2. So that doesn't factor. We're going to handle that a little bit differently. What you do have here is these two things multiply together to equal 0. So 3x squared could be 0, or x squared minus 2x plus 4 could be 0. If 3x squared equals 0, you can solve that for x. Divide each side by 3, get x squared equals 0, and then take the square root of each side, x would equal 0. And when you have that x squared equals 0, that's x times x equals 0. So that means x equals 0 and x equals 0 again. So x really equals 0 twice there. Now with this x squared minus 2x plus 4 equals 0, that doesn't factor. And if it doesn't factor, you have to use the quadratic formula. So if you remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. To solve that for x, you must use the quadratic formula. A is the coefficient of x squared, that's 1. B is the coefficient of x, that's negative 2. And c is the constant term, the number without a variable, that is 4. That's what we're going to substitute into the quadratic formula. Take the negative of b, that'd be the negative of a negative 2, plus or minus the square root of b squared, that is negative 2 squared, and then minus 4ac, that is minus 4 times 1 times 4. Don't forget, this is all over 2a, which is 2 times 1. Just keep working through that. Take the negative of a negative 2 out front, that is a positive 2, plus or minus the square root of negative 2 squared, that is 4. And then watch this next one. This is where most mistakes are made. Negative 4 times 1 times 4. Watch your sign on this. That is negative 16. Don't forget, again, this is all over 2. So under the square root sign, 4 minus 16, that is negative 12. We're looking at x equals 2 plus or minus the square root of negative 12 all over 2. Now that's square root of negative 12. You can't take the square root of a negative number, so we're going to end up with imaginary solutions. Break that square root of negative 12 down into the square root of negative 1, square root of 4, and the square root of 3. So we're taking the square root of negative 1 out, and then breaking that square root of 12 down, going to simplest radical form, breaking that into the square root of 4 and the square root of 3. Now the square root of negative 1, if you remember back to imaginary numbers, the square root of negative 1 is I. The square root of 4 is 2. So that's going to end up being 2 plus or minus 2i times the square root of 3 all over 2. That's what x equals. Now if you look at that numerator, look for a common factor that you can factor out of that numerator. 2 is a common factor in that numerator, so you can factor a 2 out. Divide each term in that numerator by 2. So if you divide 2 by 2, that is 1. Divide 2i squared root of 3 by 2, and that is going to be I times the square root of 3. Now the reason you factor that 2 out of the numerator is so that you can cancel with the 2 in the denominator. So now those 2's will cancel, and you end up with x equals 1 plus or minus I squared root of 3. So you have two imaginary solutions there. 1 plus I squared root of 3, and also 1 minus I squared root of 3. So x equals 0. That's what we got at the beginning. 1 plus I squared root of 3, and 1 minus I squared root of 3. But you might question that. Say, hey, what about the degree? The degree is 4. You should be getting 4 solutions. Where's the other one? Well, if you remember back here, when we divided each side by 3, we had x squared equals 0. That's x times x equals 0. That means x equals 0 and x equals 0 again. So I don't have it written there, but x really equals 0 twice. So the 4 solutions are x equals 0 again, 1 plus I squared root of 3, and 1 minus I squared root of 3. What are the real or imaginary solutions of this equation? X squared minus 1 times x squared plus 4 equals 0. Well, notice those two multiply together equal 0. So that means either one of those could be 0. X squared minus 1 could be 0, or x squared plus 4 could be 0. Well, if x squared minus 1 equals 0, just add 1 to both sides. You'd end up with x squared equals 1. And if x squared plus 4 equals 0, subtract 4 from each side. Get x squared equals negative 4. If x squared equals 1, take the square root of each side. Now when you take the square root of each side, you have to take into account the positive or the negative square root of 1. Because x could be the positive square root of 1 or the negative of the square root of 1. And also, with x squared equals negative 4, take the square root of each side there. And again, take into account the positive and also the negative of the square root of negative 4. So the square root of 1, that is 1. Get x equals 1 or negative 1. So positive or negative 1, that would be 1 or negative 1. And if x equals positive or negative square root of negative 4, well, that square root of negative 4, that is the square root of negative 1 times the square root of 4. So if you have the square root of negative 1 times the square root of 4, that's going to be 2i. Remember, the square root of negative 1 is I. So you're looking at 2i or negative 2i because of that plus or minus sign. X equals 2i or negative 2i. Also, x equals 1 or negative 1. Go back to the original equation, check the degree. That's how many solutions you should get. So you look at the degree of the initial equation, a little tough to pick out. But remember, the first terms multiplied together, that's going to make the degree. X squared times x squared is going to be x to the 4th, meaning you should have 4 solutions. And that's what we have here. 4 solutions are 1 and negative 1, 2i and negative 2i. If you graph this, it would only hit the x-axis at 1 and negative 1. There is no 2i and negative 2i on the x-axis. Those are the 4 solutions. What are the real imaginary solutions of this equation? X to the 5th plus 4x to the 3rd equals 5x to the 4th minus 2x to the 3rd. Need to get everything to one side equal to 0. Try to get everything to the same side of that leading term. The leading term would be x to the 5th, and that's positive. So let's get everything to that side. You're going to subtract 5x to the fourth and add 2x to the third to each side. When you do that, get x to the fifth minus 5x to the fourth plus 6x to the third equals 0. So we're taking 4x to the third plus 2x to the third and getting that 6x to the third. Now, look for a common factor that you can factor out. If you look at those three terms, x to the third is a common factor. So you can factor an x to the third out. When you do that, divide each term by x to the third, and that's what goes in the parentheses. So if you divide x to the fifth by x to the third, that is x squared. If you divide negative 5x to the fourth by x to the third, it'd be negative 5x. And finally, if you divide 6x to the third by x to the third, that is 6. Look inside the parentheses. Try to factor that into two binomials. Can you come up with two numbers that multiply to get 6 and add to get negative 5? Well, if you can, it will factor into two binomials. And those two numbers are negative 3 and negative 2. So the first terms of the two binomials will be x. That's what makes x squared. The second terms of the two binomials multiply to make 6 and add to make negative 5. That is going to be negative 3 and negative 2. So we have x to the third times x minus 3 times x minus 2 equals 0. Those three things multiply together to equal 0. So that means any of those three things could be equal to 0. X to the third could be equal to 0. X minus 3 could be equal to 0. Or x minus 2 could be equal to 0. Now with that x to the third equals 0. That's x times x times x equals 0. You have three x's multiplied together equaling 0. So that means x equals 0 three times. With the x minus 3 equals 0, just add 3 to both sides, you get x equals 3. And with the x minus 2 equals 0, add 2 to both sides, get x equals 2. Remember, x equals 0 three times, x equals 3 one time, and x equals 2 one time. When we talked about multiplicities, 0 is a 0 of multiplicity 3. 3 is a 0 or an x-intercept of multiplicity 1. It shows up once. And 2 is a 0 or an x-intercept of multiplicity 1. It shows up once as well. So the solutions here would be 0, 3, and 2. If you're asked to list all the solutions, in other words, all 5 solutions, because the degree is 5, you'd have 3 zeros, a 3, and a 2. Those would be the solutions to that equation. Now this graph is only going to hit the x-axis at 0, 3, and 2. And remember what we talked about with the shape of a graph, with the multiplicities, we had x equals 0 three times. That means the graph would appear cubic, take on an S shape where it's hitting 0 on the x-axis. And you can see that the graph is taking on a cubic shape when it's crossing through 0 on the x-axis because that 0 has a multiplicity of 3. Now the 3 that we got, x equals 3, has a multiplicity of 1. So the graph is going to appear close to linear where x equals 3. And with x equals 2, that multiplicity is 1 as well. The graph should appear close to linear where x equals 2. And you see that. It takes on a linear shape at 3, a linear shape at 2, and a cubic shape at 0. Just some reminders on factoring as you're going to need these in future sections. Always look for a common factor that you can factor out. If you have 15x to the fourth minus 20x to the third plus 35x squared and your job is to factor that, look for a common factor. Look at the 15, the negative 20, and the 35. Is there a common factor to those three? And then also look at the x to the fourth, the x to the third, and the x squared. Is there a common factor to those three? And then put those together. So the common factor to those three terms would be 5x squared. When you factor that out, you're dividing each term by 5x squared. So 15x to the fourth divided by 5x squared, that is 3x squared. Negative 20x to the third divided by 5x squared, that is negative 4x. And on the end, 35x squared divided by 5x squared is 7. So when you factor out the common factor, that is what you get. Another thing is factoring by grouping. 6x squared plus 11x minus 10. You have to do factoring by grouping when you have a number in front of the x squared other than 1. So when you see that, you're going to do factoring by grouping if it will factor. So to do factoring by grouping, you're going to split this 11x into two terms. The coefficients of those two terms will multiply to get what 6 times negative 10 is. So they multiply to get negative 60, and they add to get that middle coefficient of 11. So you have to come up with two numbers that multiply to get negative 60 and add to get 11. So think of factors of 60. You have 60 and 1, 20 and 3, 10 and 6, 12 and 5. Which pair of those can you put together to make an 11? Now, one of those is going to be negative because, again, when you multiply these, you get negative 60, and when you add them, you get 11. So one's going to be positive, one's going to be negative. And the two numbers that multiply to get negative 60 and add to get 11 would be 15 and negative 4. So that 11x is going to split into 15x and negative 4x. Now it's called factoring by grouping because of this next step. Group the first two terms together. The 6x squared and the 15x. Factor out a common factor. What is the common factor to 6x squared and 15x? It's 3x. So when you factor 3x out, that's what goes in parentheses. 6x squared divided by 3x, that is 2x. 15x divided by 3x, that is 5. Then you look at the last two terms. Look at the negative 4x minus 10. Group those together and factor out a common factor. Don't just factor a 2 out. You have to factor negative 2 out because you have to get the same thing in the parentheses in order to continue. So if you factor negative 2 out of those last two terms, divide each term by negative 2, you get 2x plus 5 in parentheses. Now you have to get the same thing in the parentheses because that's the next step, is to take out that 2x plus 5. It's just like erasing it with your eraser. If you erase that 2x plus 5, you're going to be left with 3x minus 2. So that factors into 2x plus 5 times 3x minus 2. Also a difference of two squares. If you have two terms being subtracted, two squares being subtracted in the form of a squared minus b squared, that factors into a plus b times a minus b. For example, 16x squared minus 25, that is a difference of two squares. That factors into 4x plus 5 times 4x minus 5. Once you recognize it's a difference of two squares, it's very easy to factor. The first term of each binomial is the square root of this first term. The square root of 16x squared is 4x. And then the second term of each binomial would be the square root of this second term. The square root of 25 is 5. Then do a plus and a minus. So that factors into 4x plus 5 times 4x minus 5. Don't forget, difference of two squares. More factoring by grouping. If you have ax plus ay plus bx plus by, you can factor that by grouping. Group the first two terms together, the ax and the ay. A is a common factor of the first two terms. When you factor that a out, you're going to be left with x plus y in parentheses. And also group the last two terms together, bx plus by. B is a common factor of those last two terms. If you take that out, again, you get x plus y in parentheses. You have the same thing in the parentheses, so that can be factored out of those two terms. If you take an x plus y out of each term, you're going to be left with a plus b. So that factors into a plus b times x plus y. You can apply factoring by grouping to this. X to the third plus 2x squared minus 3x minus 6. Look at those first two terms. X to the third plus 2x squared. Is there a common factor to those first two terms? X squared is a common factor. So if you factor an x squared out, divide each term by x squared, that's what goes in the parentheses. X plus 2. Then look at the last two terms. Negative 3x minus 6. Is there a common factor there? Keep in mind, if you're doing factoring by grouping, you want to end up with the same thing in the parentheses. So if you just factor 3 out of those last two terms, it's not going to cut it. You have to factor a negative 3 out of the last two terms so that you get the same thing in the parentheses. So we have x plus 2 in both sets of parentheses. That is a common factor of those two terms. You can take that out. If you take x plus 2 out, you're going to be left with x squared minus 3. So that actually factors into x squared minus 3 times x plus 2. Earlier we talked about a sum or difference of two cubes. Sum of two cubes, a to the third plus b to the third. That factors into a plus b times a squared minus ab plus b squared. And we've had a difference of two cubes, a to the third minus b to the third. That factors into a minus b times a squared plus ab plus b squared. Note the difference on those. When you have a sum of two cubes, a to the third plus b to the third, the sign in the binomial is going to be the same as what you're factoring. But the sign in front of the ab is going to be different than what you're factoring. In a difference of two cubes, the sign in the binomial is going to be the same as what you're factoring. But the sign in front of the ab, again, just like the one before, is going to be different from what you're factoring. So that's one way to remember how to factor a sum or difference of two cubes. Everything else stays the same. Here we have 8x to the third plus 1. That is a sum of two cubes. That's in the form of a to the third plus b to the third. That's going to factor into this form, a plus b times a squared minus ab plus b squared. Well, if you figure out what a and b are, then you can fill in the rest. So if a to the third is 8x to the third, then a would be the cube root of that, which is 2x. And if b to the third is 1, b is the cube root of that, which is 1. So we know that a is 2x and b is 1. So this is going to be 2x plus 1 in that binomial. So in the binomial we have 2x plus 1. We know that a is 2x, so in the trinomial this a squared would be squaring 2x. That's 4x squared. And then minus ab, well, we know that a is 2x and b is 1. So ab would just be 2x. It's going to be minus 2x. And then finally, b squared, we know b is 1. So b squared is going to be 1. So that 8x to the third plus 1 factors into 2x plus 1 times 4x squared minus 2x plus 1. That was a sum of 2 cubes. Now for a difference of 2 cubes. 27x to the third minus 8. All of those are perfect cubes. So 27x to the third is a perfect cube, and 8 is a perfect cube. So that is a difference of 2 cubes. It's in the form of a to the third minus b to the third. That factors into a minus b times a squared plus ab plus b squared. Again, try to pick out a and b. If a to the third is 27x to the third, then a would be the cube root of that. So a is the cube root of 27x to the third. That's 3x. And if b to the third is 8, b is the cube root of that. Cube root of 8 is 2. So we know that a is 3x and b is 2. So in that binomial, a minus b, that's going to be 3x minus 2. Now for the trinomial. A squared, we know that a is 3x, so a squared is going to be this 9x squared. Just square that 3x, it's 9x squared. Now for ab, we know that a is 3x and b is 2, so a times b would be 6x. And on the end, b squared, we know that b is 2, so b squared is 4. So that difference of 2 squares, 27x to the third minus 8, difference of 2 cubes, 27x to the third minus 8, that factors into 3x minus 2 times 9x squared plus 6x plus 4. Don't forget your factoring.